This is lesson 2.2, Math 020 Pre-Algebra. In lesson 2.2, we are going to evaluate, simplified, and translate algebraic expressions. So we're going to start with the variable expressions. Variable expressions are series of statements, combination of numbers and letters, separated by an operational sign. So here we have an example. So here we have negative 4xy. So you have a combination of number and two variables. You have 7n squared. So that's another combination of number and a variable. And then we have a squared bc to the power of 7. So we have three terms. So those are terms. And they are separated by an operation symbol. So either plus or minus. So that is what your variable expression means. Okay. So when we the first thing, our first skill of the day is to be able to evaluate expressions for a given value. Right. So in these series of problems, you will be given an expression and you will be given a particular value for your variable. So your goal would be, your task would be, is to take that value, drop it instead of, in place of your variable, and evaluate your expression. So let's go ahead and look at the first one. Our expression is, in the first problem, our expression is 8x minus 6, and the value of x is 7. So the first thing that I'm going to do is I am going to rewrite the problem using the particular x value. Instead of the variable, I am going to use the 7. So 8x means 8 times x. So I'm going to do 8 times x is a 7. So 8 times 7 minus 6. All right. So that is your step one. You rewrite the expression using the particular value for your variable. And then the step number two, you evaluate the expression using order of operations. So here we have multiplication and we have subtraction. So we'll do the multiplication first. So that's going to be 56. 8 times 7 is 56, minus 6. And now we only have one operation, so 56 minus 6 equals 50. All right, moving on to part B. We have an expression, n squared plus 3n minus 8. And we need to evaluate that for n equals 6. Again, your first step would be take the value of n equals 6. So take the 6, and everywhere you see the n, you're going to use the 6. Okay, so let's go ahead and rewrite our problem using the given value. So I have 6 squared plus 3 times 6 minus 8. Okay. So I replaced my variable with a given value. The next step is to calculate the result using order of operations. So looking at the problem, I have exponent multiplication, I have addition, and I have subtraction. So I'm going to start with the exponent. 6 squared, 36 plus 3 times 6 minus 8. My next step would be multiplication. So just remember, you have grouping symbols, you have exponents, multiplication or division, and you have subtraction or addition. So if you need to have your gems handy somewhere, write it on a piece of paper and have it handy next to you. So 3 times 6 is 18, so I have 36 plus 18 minus 8. All right, now I have addition and subtraction. Because they are of the same importance, I am going to do them one after another. So 36 plus 18 will give you 54. And the 54 minus 8, that would be my last step. And that would be 46. Okay. Moving on to the next problem. Okay, in part C, our expression is x minus y, and that whole expression is squared. And I do have two values to replace now, x equals 9 and y equals 6. So I am going to drop the x, use the 9 instead of x, and I'm going to use the 6 instead of y. So I have two replacements to complete. So I'm going to go ahead and do that. So my problem looks like this now. 9 minus 6, still squared. Okay. So this is a very small problem, but it does have order operations going on. I do have parentheses, so I'm going to do that first. 9 minus 6 is going to be 3, and then I have to do 3 squared. And again, just a reminder, 3 squared is 3 times 3, which is 9. So that is our answer. Okay. So the next problem is slightly different. We have some squares again, and we have two variables again to replace with two values. So I have the r, which is 12. So I'm going to replace that with r. And I have an s, which is a 5, and I'm going to replace that with the s. All right, so let's go ahead and rewrite this problem. So I have 12 squared minus 5 squared. All right. So I have two exponents. I'm going to do the first one, 12 squared. So 12 squared means 12 times 12, which is 144. So I have 144 minus 5 squared. All right, now 5 squared is 5 times 5, which is 25. So I have 144 minus 25. I just need to subtract 144 minus 120 minus 25 will give you 119. Okay, so r squared minus s squared evaluated for r equals 12 and s equals 5 will give you 119 as the result. All right, the second concept in lesson 2.2 is the like terms. Okay, so the like terms are the combination of numbers and the variables that have exactly the same variable raised to exactly the same power. Okay, so that's what we're going to write. So like terms have exactly the same variables raised to exactly the same power. Okay. So what do we do with the like terms? We combine like terms. All right, the only thing that we do, we combine like terms. And when I say combine, I mean add like terms. So that's the reason why we study them, because the only thing that we can do with like terms is combine them. And when I say combine, I mean add. So to combine like terms, you're going to go through these 3 steps. Step 1, you're going to identify like terms. So that means that you're going to be looking for exactly the same variables raised to exactly the same power. For step 2, you can rearrange the expressions so like terms are together, And then for step 3, you're going to add the coefficients of the like terms. The coefficients of the like terms are your numeric numbers in front of your variables. Coefficients are numbers. Okay, so remember we talked about the variables and constants. So coefficients are your constants, numbers. Okay, so let's go ahead and look at our examples. All right, to simplify the following expressions. All right, the first one is 4x minus 15x. That one actually we need to change to 4x plus 15x. Because we're not ready for the negative numbers yet. Right, so let's double check. We have the like terms because both terms of 4x and 15x have the same variable, and the variable is x. So I have the x and the x. All right, so that is my like term. So when I combine it, I keep the like term, and I'm going to add the numbers. 4 plus 15 will give me 19. So to come 4x plus 15x gives me 19x. Okay. So part B, your expression is 6y plus 4y plus y. The tricky part here is that y does not have a coefficient in front of it. There is no number attached to y. So we're going to use our identity property of multiplication, where we said that a number multiplied by a 1 is the same number. So the same applies to a variable. So I can drop the 1 in here. If I don't have a number, that means the number is 1. Now, all my like terms are y's. So every variable is a y. So I'm going to keep the like term, my y. And I'm going to add the numbers, which is 6 plus 4 plus 1. It's going to give you 11y. So y 11 because 6 plus 4 plus 1 equals 11. Okay. So part C. Here, things getting a little bit more interesting. You have some terms with a variable. You have 8a and 5a, but you also have a number 9. 9 does not have a variable attached to it, so 9 is not going to be a part of the like term combination. So the only two like terms that I have here that I can identify is the a terms, because they have the variable a. So I'm going to combine 8a plus 5a, and I'm going to leave minus 9 alone. Okay, so 8 plus 5 is going to be 13. The term was a, and then minus 9. I'm just going to copy it down, and sometimes that's all you can do. So you have the answer is 13a minus 9. Okay, very similar. We're going to do part D. So the next expression is 8p plus 5 plus 2p minus 6. All right. So it's easy to see that we do have same variables. We have 8p and we have 2p. So those are the like terms here for us. Remember when I gave you the rule, identify like terms, rearrange the expressions so like terms are together. So this is where you, on the longer problems, you might want to start doing that. So let's go ahead and rearrange that. So I would rewrite 8p plus 2p. So now the p terms together, and then I'm going to copy down plus 5 minus 6. All right. Some people underline, circle, or color code their like terms. That works too. Rearranging them is one of the ways of identifying like terms and putting them together. So now I can do this. Okay. So 8 plus 2 is 10. 10p plus 5 minus 6. And I can combine these two, 5 minus 6. We're jumping it a little bit ahead here because the answer is negative. So 5 minus 6 is a negative 1. You will not have negative values on your homework, but it's really hard to do any kind of combining like terms without negative values. So you would combine 5 minus 6, give you negative 1. So the answer would be 10p minus 1. Again, on your homework, you will not have negative values, but I thought that you might benefit from just getting a little bit of a taste of what's coming. Okay. So let's go ahead and look at the last one, the last couple of problems. And then we have the 2.4 coming up. Okay. All right. So here we are again. We will not be able to avoid negative numbers. So we're going to go ahead and do those. Okay. So in part E, you have 7n minus 4 minus 6n plus 3 minus 9n plus 1. So I have, as far as I can see, I have some n terms, 7n, negative 6n, negative 9n. So all these have the same variable n. So those are the like terms. But then the numbers are also like terms. So I have 4, I have 3, and I have 1. So I have two sets of like terms here. One that has the variable, one that doesn't. So I'm going to go ahead and rewrite them. 7n minus 6n minus 9n. Okay, so that's one set. And then I have minus 4 plus 3 plus 1, right? So I'm going to do my variable part right here. And then I'm going to do my number part right here. Okay, so 7 minus 6 is going to be 1. And 1 minus 9 is going to be negative 8n. All right, and then I'm going to look at the number part. Negative 4 plus 3 is going to be negative 1. And negative 1 plus 1 is a 0. So the only thing that's left is the negative 8n, because negative 4 plus 3 equals negative 1. Negative 1 plus 1 equals 0. Numbers are gone. So the only part that we have is the variable part. All right. And here we are at the very last problem for this lesson. Let's take a look at what we have here. We have 5x squared minus 9x minus 10 minus 2x squared plus 3x plus 4. So here we will be having 3 sets of like terms. I have the x squared. Okay. These are not the same as x's because the definition of the like term, and let's go back to that again. Like terms have exactly the same variables raised to exactly the same power. So it's not enough to have the x. It has to be to the same power. So I clearly have 2 square terms. I also have 2 regular terms. So I have 2 x's. All right, let me just fix that a little bit. So I have 2 x's. And I also have, on top of everything else, I also have some numbers. All right, so 3 sets of different like terms. So let's go ahead and rearrange them. I'm going to start with the squares. I have 5x squared minus 2x squared. So now they're together. In terms of x's, I have negative 9x plus 3x. Okay, so once you start rearranging the numbers, you always want to take the number or a term with the sign that is preceding it. So if there is nothing in front of it, it means it's a plus. But here, when I had to grab my 9x, I had to take the negative sign as with it as well. Okay, so all terms come with a sign in front of them. So 3x, and now I'm going to grab the 10, which is a negative 10, because there's a minus sign in front of it, and then plus 4. Okay, so just so we're clear on what we're grouping together, the squares are going to go together, the x's are going to go together, and the numbers are going to go together. So those are the three groups of terms that we have. All right, so 5 minus 2 is a 3. So in squares, I have 3x squared. Negative 9 plus 3 is a negative 6, so I have negative 6x. And I'm just writing down negative 6x and see how it falls into place that I have 3x squared minus 6x. And then negative 10 plus 4 is a negative 6. So again, this is your answer. You just double check that you haven't missed anything. You have a square term, you have an x term, and you have a number. This is our official answer.